Our next speaker is Dr. Ricardo Galante. Dr. Ricardo is a passionate educator and lifelong learner. Professor Ricardo has dedicated his career to inspiring future leaders in data science, analytics, and artificial intelligence. As an invited professor at the University of Lisbon, IPAM, Universidad Europea, and European University, he transforms classrooms into spaces of discovery, blending academic rigor with real-world application. His mission is to awaken critical thinking and empower students to use data as a tool for innovation and positive change. With over 20 years of experience, Ricardo also serves as a principal analytics and artificial intelligence advisor at SAS Portugal, where he drives organizations to harness the full power of analytics. His expertise spans machine learning, segmentation, behavioral modeling, and credit scoring, delivering breakthrough solutions through cutting-edge research and innovation. Throughout his journey, spanning leadership roles at SAS Brazil, Allianz Brazil, Cognitis, Acnilson, and the Secretaria de Estado de Educação do Rio de Janeiro, Ricardo has combined technical mastery with a deep commitment to human development. A dynamic storyteller, sought-after speaker, and active mentor, he believes that true success is not only about solving complex problems, but about inspiring people to see new possibilities, whether in the classroom, on stage, or working alongside businesses. Ricardo is driven by the conviction that knowledge shared is power multiplied. Please join me in welcoming our plenary speaker, Dr. Ricardo Galante.
Okay, thank you very much for this kind introduction, Kiran. Let me share my screen with you, guys. 1 second.
Perfect.
Okay. Can you see my
It's perfect.
Okay,
Yes.
perfect. Hello, guys. It's a real pleasure to be here with you. Okay. Today we'll exchange some information about trustworthy AI. Okay, some points of view that I am working here in Iberia, mainly in Portugal. Okay, so Kiran made a very kind of introduction about myself. My name is Ricardo Galante, and I work at SAS company. I am a statistician. I did a master's degree in Bayesian, inference Bayesian, and I'm finalizing my PhD university in Lisbon at Lisbon University, related with machine learning, but mostly related with forecasting. It's a cool thing. If you want, we can change some information about this. And I work a lot with artificial intelligence. In fact, I am a teacher in some universities here, Lisbon University, European University, and so on. And I teach data science using a lot of I think different approaches, okay, to teach our students in this way. So let's start our conversation, our journey, okay? Artificial intelligence. When I start to talk about artificial intelligence, we need to talk about this kind of thing. We need to talk about the evolution. And you know, it's not new. We start this kind of conversation in the 50s, okay, with Alan Turing, with Frank Rosenbaum, when they start talking about the perceptrons, the Alan Turing, and so on. So this is not new, but from there we have a lot of evolutions. In fact, we have evolutions day by day, daily. We have different things appearing each day related with artificial intelligence. Here I put the main. It's not all, of course, because we have a lot of things, but I put the main topics: machine learning, deep learning, generative AI, NLP. So, and this is more or less our timeline related with artificial intelligence over the time, okay? And we have some good points. We have, when I did some researchers about this, and we had a lot of financial investment related with artificial intelligence starting 2021. It's not from there, but I choose this timeline until 2024, and is expected to have a much more financial investment, okay, until 2030, okay? A lot of investment in this area. You know this, you know, we are all working with this kind of thing. But in the opposite, we have problems, okay? It's not is not so perfect. And here I put some problems, documented problems that started appearing in 1988. I think we had much more problems, but I think I put here some documented problems. Okay, in this case, were related with bias in a hospital, and I put different problems along the year. Okay, over the time, and here we have much more. Each ball here represent a problem related with bias, relate with a lack of privacy and things like that. So it's a problem. It's a problem. In fact, we have this kind of situation. We have the two sides from the same coin. We have the risk of using AI, as we saw right now, and we have the reward. Okay, so it's not possible to avoid risk. We need to live to convive with this kind of thing, and we need to have the reward related with the use of artificial intelligence. And how can we do this? We can do this with trustworthy AI. This is the idea. Trustworthy AI is a way to combine or to put in the same equation the risk and the reward. Okay, and I put here this exactly this thing. Okay, the balance between the risk and the reward related with artificial intelligence. So trustworthy AI is the idea is to develop and use artificial intelligence in an ethical way, in an ethical manner. Okay, we can talk about ensure that AI does not harm people or harm society. This is the most important thing related with ethical AI. This is a cool thing. We need to change the way that we are asking. Not could we, but should we? This is the idea of trustworthy AI. And when we talk about the business related with artificial intelligence in an academical way or an industrial way, we need to reflect which value this brings to us, not only to myself as a person, but to our society, our countries, our kids, our generation, and so on. This is the idea of trustworthy AI. Okay, but why should we care about this? What is the problem? Why this is so important? Okay, we could think in a different angles. We could think in we want the well-being from the humankind, for the society. But in fact, here we have at Europe the regulation called AI Act. Okay, I talk here a little bit about this kind of regulation, what does mean, and what is the impact in our lives. Okay, in terms of academic and industrial way that we will work from now on. Okay, so the point is, this is the definition of a AI Act. Okay, is a European Union regulation that govern develop. The focus is use artificial intelligence within the Union European. Okay, the goal is to ensure that AI systems are safe, respect fundamental rights, and foster a competitive UI AI market. This is the definition of this regulation. Okay, and here I put I think some interesting point, because it's not new. This is starting 2018. Okay, when the Commission from Union European they agreed to create a document like, okay, let's work. We need to work with this, but let's create some rules. Let's create some guidelines. Okay, about this kind of thing. And here I put the entire timeline about the AI Act. The beginning, okay, in 2018, and you have different guidelines or points over the time until March the last year, when the law was approved. Okay, I put here the information about Portugal. I am in Portugal, but I put here the Portuguese law and the Spanish law. We have different laws, each one by country. We have in French, Belgian, United. We have, for instance, in some countries that they create by law, trying to be agreed with the main one related with AI Act. Not only by countries, but we have the same law divided by industries. For instance, here I put EIOPA. EIOPA is the regulation related with AI Act, but for insurance companies. So it's not only related with countries, it's related with industries itself. Okay, this is the idea. Everyone is concerned about this kind of thing. How can we use AI but in an ethical way, in an ethical manner, okay? This is the point. So what are the challenges? Here I put some challenges that we are facing, okay? The point related to transparency and privacy, the explainability of models. We have very good models, but how can I explain my models that I am using? Points related with bias and discrimination, okay? This is a very important point. And how can we work with this in an ethical way, in a way that I will avoid harm to people, okay, or harm organizations. And when you take the AI Act, was created some levels of risks. Okay, we have from level 1 until level 4. We have the level 4 is the minimal risk when we are using artificial intelligence. It's totally allowed because video games, anti-spam filters, and so on. When you are in the level 3, we have low risk. We have risk, but in a low way. Is related with chat bots, call bots, voice bots. When you enter in the level 2, in the second level, we have high risk. Okay, and this could affect it. Okay, this could be a problem related with classification, and in this way we can have bias. We could have some constraints in terms of people or gender, ethnicity, and things like that. And we have the unacceptable risk. Okay, it's a prohibited AI practice. All these things were created in the AI Act. Okay, of course we work with the high risk because it's, I think, the most important thing. The minimal and the low, it's not a problem. And the unacceptable, we are not accepting this kind of thing. So this idea is put our focus in the right risk level. Okay, so one thing that this is the pillars that we have in the AI Act, in the human centricity. We could have very good models, very automatic models, but we need to have the human in the center of the process, taking decisions. We need to be transparent in our data, in our algorithms. We need to be inclusive. So it's not possible to exclude some group, okay, based on ethnicity, based on the religion, the religion of these people, or gender, and so on. Need to be robusters, okay, in terms of assurance, in terms of process. I need to be need to be accountable. I need to identify the responsibles of things, and in the end of the process, we need to respect the privacy of the data. So this is more or less the pillars that we have in the AI Act, and they are inclusive in this process. When we think in a software, or when we think in a process that work with intelligence, with artificial intelligence, we need to take in consideration this kind of thing. Okay, so I work at SAS. SAS is a company. I don't know if you know, but I work at this kind of company. SAS is an American company. The SAS means, this acronym means Statistical Analysis System. This company is in the market, I don't know, a long time ago. We entered the market a long time ago. And we work with statistics, with artificial intelligence, advanced things. But how can SAS could help in this context? Okay, in this context related with artificial intelligence. So this is the structure that represents a SAS as a software. SAS is not only an algorithm or a dashboard or a model. SAS is a platform, a complete platform. We have some modules. We have the first module is related with data, the data ops, the data governance. The second module is related with analytics. Since from the basic statistics like a Q-square model or correlation, until the deep learnings, the LLMs, and so on. So is the moment where we create, or the place where we created analytics. And the last part, the third part, is related with deployment of the process. What does mean deployment? It's related with the process when we put in production. For instance, suppose that you create a model and you need to put this in a cell phone to be run it, to do like a recommendation or a credit score analysis, things like that. So the model was in our mind, the model was created not only to to be in our computer, but should be placed in secret turbines and computers and websites, cell phones, video cameras, and so on. So this is the idea. SAS is not related with one of these parts, but all of these parts. So for this reason, I put this image representing the platform. And here I put the modules, the interface, okay, of each one of these parts, the data preparation, the information catalog, where we have all the information about the data. Think this in a bank or in a hospital or in a energy company. And here we could have the information about all the data that we have, the data discovery, the automated analysis. The data mining is very cool because here you can work, of course, with SAS, with advanced analytics, but you can integrate with any kind of open source. You can work with Python, R, Databricks, and so on. For this reason, I put the open source here. Okay, this is our interface related with Jupyter Lab. Model management is a possibility to have all these models in the same place. Okay, like a repository. Suppose that I create models in SAS, but I create models in R, Databricks, H2O, Python, and so on. And I could have all these models in the same place. Okay, to not only to have a repository, but also to manage these models. For instance, to check when these models is not so performatic, when it is necessary to retrain the models. And the last part is the intelligence decisioning part, is the possibility to integrate these models, these structures with decisions. Okay, so this is called intelligence decisioning. So more or less in a general way, we have here the main parts related with SAS. And my intention is do a demonstration, a quick demonstration for you guys. A good thing that I would like to share with you is that we have the same platform in academic way. That means that we have this for free, okay, for free. We could use this, of course, in academic way, but even I have my academic mail, I can use this inside universities to do research, to teach my class. For instance, I teach my classes using SAS. Okay, my students and my colleagues learn from my classes using SAS, integrating with open source and so on. So if you have any doubts, please contact me and we can talk about this. How can we use this? How can we use SAS in academic way? But this is the idea. I will do a demonstration here, and my intention is like I will think that I am simulating a financial context where we have a default credit card customers. So we have a table, okay? It's a simple table which each line represents a customer with a lot of informations. That we have demographic information. We have the relationship from the customer with the banks and a lot of things. And we have the information about these guys related to if they pay or not pay a credit card. Okay, it's a simple one. It's a classification model, but my intention here is present to you a combined way to see every part of the analytical platform. And in my demonstration, I will work with this. This is considered a high-risk model. Why this is considered a high-risk model? Because I am classifying my customers, okay? And this is a high risk because I could put, for instance, gender. I could use, for instance, ethnicity and things like that, and this could harm. This could be a problem in a company. Provide or not, for instance, a credit or insurance. If a guy have a gender A or B or have the kind of ethnicity or things like that, this is a problem. For this reason, this is considered a high risk model. And the flow that I will use is more or less this one. I work with data. I will model. I do the management of the models, okay, and I will deploy the process that I am working, okay. So let's move on. I'll go to the demonstration. Let's exchange the screen here. 1 second. I'm assuming that you are seeing the blue screen.
Yes, we can see.
Okay, perfect. So this is the this is the cockpit, okay? The entrance cockpit from SAS. I will work with this data set. Let me show you. This is a simple one, the same that I showed to you some seconds ago, okay, related with credit card default, okay? And here we have one sec, here we have the entrance cockpit. So here we have the different parts: information, assets, develop code, explore, build models, manage models, build decisions. This part represent the image that I show you, okay, related with each part of the SaaS platform. So I only for you see, I can go here and came here and click on manage data, only for you see that we could, of course, I can import local files as we have here, but I could have, for instance, if I click in add, we have different connectors. So I could use Amazon MRM, I could Redshift, I could, for instance, different clouds, Databricks, Google Data Proc. I can use here, I can select here different ones like Salesforce, SAP HANA, and so on. So it's only for you see that every connectors, or the majority of them are here, okay? I need only to use them if I want, okay? In my case, I will import the data set, this local data set that I show you right now. I will select a data. In fact, I already did this, and I will move on to the information catalog. Here we have the information about the data set that I show you related with default credit cards, okay? This is a Portuguese data, okay? We have a different information about some customers. And here we have, is very interesting because in automatic way, SAS provides us with like a summary of the data. This part is not created by myself, was created in automated way when this data set is related with this information, related with, we have this kind of variables and so on. And here, in automatically way, it provides us what the variables I mean, is like a columns that I have in my data set. We could have here the information about what does mean a private variable, what would be a sensitivity variable. I didn't do anything. This is automatic in automatically way. He is putting pointing me out that this variable could be a private variable related with age. If I have here gender, it will be the same. And here I could see, I could check the variables. Okay, each line here represents a column in my table, and we have the distinct values, the mean, arithmetic means, okay, and an average. In fact, the median, the minimal value, the maximum standard deviation, missings, skewness, kurtosis, the quantiles related with the distribution of each variables. We have here the metadata measures, and I think the most the point that I really like is related with the quality. So here we have the completeness, the uniqueness. We have the most common value, the less common value, and a lot of information that could help us to identify our data. For instance, if I click here in loan, in this variable, I just click here, and now we have the information about, of course, the information in a statistical way. We have the distribution of the variable. We could see here a graph with the skewness and kurtosis, and here we have the box plot. So a lot of information. This is cool because I could check this data before start a model, okay, before start a model. So after this, I'm moving in my analysis, okay. I pass to the exploration part. I will do this in a quick way, only for you see the main parts. And here I did this only for you see. Okay, and here okay, let me put here, I will view report only for you to be better for you. This is the data, okay. I am in the reporting part, I'm in the exploration part. This is the data that I show you, and here we have an overview of the information, okay. Here we have, this is the map of the Portugal map, okay, but could be Turkey, could be United States, could be anyone. In this case, as I am using a Portuguese information, I have the Portugal, okay, here in my map. And of course, these things are totally related. We can see this combination. And here we have the descriptive and its descriptive statistics here, the quality measures, the same that we saw before. And here, a very cool thing. Suppose that I will do this. Let me do in a different way. I will do this. I will do it alive with you. Suppose that I want to do a model in automatic way. I can go here. Bet is the variable. That means that represent the guys that pay or not pay the loan, okay, the credit that they made. If I click here and select explain, hey SAS, explain to me on this current page. If I click here I have the model in automatic way. And now we are having the most important variables until the last important, the less important variables in a very easy way, okay? And here we have the explanation of each one of these variables, okay? Only for you see that is totally automatic, and I can create different models. I call this business model. I have a decision tree, I have a logistic regression, I have a random forest, and I have a gradient boosting here. I did this in a very easy way, and we have the model comparison. Show which was the best one. But this is not a data scientist thing. This is a more business business guy, business analyst. Okay. Suppose that I am a data scientist. I could came here in the same SAS, in the same structure, and I go in the build models part. Okay. 1 second. This content is blocked. Let me. 1 second, guys. This is different for me. I don't know what is happening here, but I will try for the last time. Reviewed models. 1 second. Let me do this. It's alive, okay? This kind of thing happen when we are working alive. Okay. It's quick. 2 minutes more. I will finish my presentation. I don't know. Uh-oh. One second. I do this. I go in a direction, different way. I log in here. I am almost finished my presentation. I would like only to show you the governance part, because I think this is very important.
Yeah, no problem, Professor.
Okay, thank you.
Yeah, please go on.
Okay. Yes, I think now, yeah, we are good. Okay. And so I came from this part exploration, and I go to the build models. In this part, we can create models. I will open the project that I created. Okay. And only for you see, I create some models. We call these pipelines. Okay. I create models. This is the data, this blue box. And I did some imputation, and here I have a Python model. Okay, if I open here, you can see the Python code. It's a simple one, but it's only for you see that I am using a scikit-learn here. Okay, I have an R model here, and I have a gradient boosting here, and I have an advanced pipeline with a lot of this. Each box that we have here are a different algorithm. This algorithm was created by this part here. I will create a pipeline, the pipeline number 4, for instance. Only for you see the how can I create from scratch, okay? This pipeline. Here you have different algorithms. So anomaly detection, clustering, feature extraction, feature machine, and you have the supervised learning, a lot of algorithms, Bayesian inference, GAN models, post-processing and keyword, and miscellaneous. We can work with open source and so on. And in this case, I created some models combining different informations. And but the most important part is some details that I have here. I will open this gradient boosting here only for you see. And here we have, I am open the gradient boosting. In this case, we have the normal things, we have the ROC, KS, and so on, the assessment related with gradient boosting. But here we have the model interpretability. This is a very important thing that we have. Remember that we are working with a gradient boosting. It's a machine learning model. It's very difficult to interpret. It's very difficult to understand the parameters. And here we can see, for instance, suppose that I work with this variable, the value of the loan, okay? Here we can see the probability, when the probability is increased or not, based on the model that we created. And here we could have the same variable, but divided by clustering. This means that SAS create a segmentation in the data and create different models for each segment. It's a very cool thing. It's a very cool thing. And now I can interpret my model, but using this kind of thing. Because if I look in the parameters, it will be impossible. And the last thing is related with fairness. And these we have the different variables. And in an automatically way, we have the bias being analyzed. And I could, here we have some variables, job, for instance, we have the reason of the loan. And we could see with different metrics like Max, Komogorov, Smirnov, or multi-class log, and check if you have or not bias in our models. And from this, we can work with in a process to mitigate this bias. To finalize my presentation, I will go to the managed models, that part that I show you, that we could have we can governance the process, the entire process. And here we have the models that I created in that interface. Here we have the different models. We have open source models, R, Python, and so on. And this is a very cool thing, because here is like a cockpit where allows us to work in a governed way. And I could here, for instance, I could check the performance of the model. And if I click here in the gradient boosting, we could see, for instance, this is like a snapshot from the model over time, okay? Suppose that model was published in different periods of the time. So I could came here and, for instance, I click in loan, for instance. We could see here in the first, suppose that was first quarter, second quarter, third quarter, and fourth quarter. Here we have the distribution of each variable in this quarter. I could check here and identify, for instance, which variables are stable or unstable. Suppose I think I have some stable variable. Let me see. For instance, this one is very stable because every quarter we have the same distribution. Did you get it? My point. Here we have unstable when I click here, because we have different formats. But when you have the same line represents a very stable variable. And we have a lot of information that we could explore. If you have time, I can explore the very details. And to finalize my presentation, we can publish. So I can came here, and let me put this part here. I can came here, for instance, select a model that I would like to work, and publish these models. And in this case, I can put this in my case here, in my demonstration. I don't have a lot of destinies, but here I could have clouds, for instance, Azure, Google Cloud, AWS, or even GitHub. So I could put in a different destinies and publish this model in a different way, or put this in production in a different way. So guys, this is more or less the thing that I would like to share with you. Let me go back to see you. Okay, 1 second. One second. Yeah, now I can see you. So this is more or less, I think we have a lot of things. I show you only the top of the iceberg. We have a lot of things. But if you have any doubts, it's a pleasure to help you or to answer the questions.
Yes, please, Dr. Ricardo. Congratulations for the most beautiful presentation.
Thank you.
I would like to learn. If you want, we can make a meeting So
Of
I can
course.
give you data and see how it goes through Python and what happened to the data.
Perfect. Let's have this conversation. Will be a pleasure. Will be a pleasure.
Wonderful. Any questions? So what do? You take the data, right?
Yeah. Yeah.
And then you put it there, and then it goes through all the rest of the, then it
Yeah.
gets processed.
In
It's
automatic
all
way.
with Python, yes?
Yeah, you have a Python. You can code using Python inside SAS, or suppose that you use Python in your Spider or Jupyter Lab or Jupyter Notebook. You can connect using some APIs. We call this SAS CTL, and you have the Python code, and in automatic way, this code will be connected with this environment that I show you. Okay, in totally automatic. So you can choose. You can work with Python or R or inside SAS or outside SAS, and have these graphics, these visions. So it's easy. It's very cool. It's very cool.
Wow. We are open for questions, please. Thank you so much, Dr. Ricardo.
Was a pleasure. Was a pleasure.
We'll go to the next